Good day, everyone. My name is Adriana Shakira bint Abdulmuiz, and today I'll be presenting on my topic, MOSFET applications in a pulse oximeter. In this video, I will explain what a pulse oximeter is, how it works, and most importantly, the role of the MOSFET in controlling the circuit and improving the performance of this biomedical device. What is a pulse oximeter? Pulse oximeter is a non-invasive biomedical device that measures two important health parameters: blood oxygen saturation, also known as SpO2, and pulse rate or heart rate. The device is commonly clipped onto a patient's fingertip and provides quick, painless, and real-time monitoring without the need for blood samples. Pulse oximeters are widely used in hospitals, clinics, emergency departments, and home healthcare, especially for patients with respiratory or cardiovascular conditions. Because of its portability and ease of use, it has become an essential medical monitoring device. A pulse oximeter operates using two different light sources: a red LED with a wavelength of 660 nanometers and an infrared LED with a wavelength of 940 nanometers. These LEDs shine light through the patient's finger. Oxygenated and deoxygenated blood absorb these wavelengths differently. The remaining light that passes through the finger is detected by a photodiode. The electrical signals produced by the photodiode are then processed by the device to calculate the patient's blood oxygen saturation and heart rate. This optical measurement technique allows the device to provide fast and accurate results without being invasive. What is a MOSFET? MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. It is a semiconductor device that is widely used as an electronic switch in many electronic systems. Unlike mechanical switches, a MOSFET uses voltage at its gate terminal to control the flow of current. Some of its main functions include signal control, power management, and electronic switching. MOSFETs are preferred because they offer high switching speed, low power consumption, and high efficiency, making them ideal for battery-powered medical devices such as pulse oximeters. This slide shows where the MOSFET is positioned within the pulse oximeter circuit. The battery supplies power to the system, while the LED driver controls the MOSFET. The MOSFET then acts as an electronic switch that regulates the current supply to the red and infrared LEDs. By controlling these LEDs, the MOSFET ensures that only one operates at a time. This prevents signal interference and allows the photodiode to detect each wavelength separately. As a result, the pulse oximeter can obtain accurate measurements while consuming very little power. This makes the MOSFET one of the most important components in the circuit. This slide explains how the MOSFET controls the operation of the LEDs inside pulse oximeter. First, the MOSFET turns the red LED on while the infrared LED remains off. During this time, the photodiode receives and measures only the red light signal. Next, the MOSFET switches off the red LED and turns on the infrared LED. The photodiode then measures only the infrared light signal. This alternating switching process repeats continuously at a very high speed. Because the red and infrared LEDs are never on at the same time, the photodiode receives one signal at a time without interference. As shown in the timing diagram, the photodiode alternately reads the red and infrared signals, allowing the microcontroller to compare both measurements and accurately calculate patient's blood oxygen saturation. The simplified circuit shown below demonstrates the basic switching principle of MOSFET. When a control voltage is applied to the MOSFET gate, current flows through the LED and it turns on. When the gate voltage is removed, the current stops and the LED turns off. In an actual pulse oximeter, the MOSFET performs this switching function repeatedly to control both the red and infrared LEDs efficiently while maintaining low power consumption and ensuring accurate measurements. There are several advantages of using MOSFETs in pulse oximeters. First, MOSFETs provide fast switching, which allows precise control of the LEDs. Second, they consume very little power, helping to extend battery life and making portable devices more efficient. Third, they generate very little heat, improving safety and reliability during continuous operation. In addition, MOSFETs are highly efficient and compact, making them suitable for small biomedical devices where space and energy consumption are important considerations. These advantages contribute to better overall performance and longer operating time. This diagram summarizes the complete operation of the pulse oximeter. The battery provides power to the system. The LED driver sends control signal to the MOSFET, which alternately switches the red and infrared LEDs. The emitted light passes through the patient's finger and reaches the photodiode. The photodiode converts the received light into electrical signals. These signals are amplified and converted from analog to digital form by the ADC before being processed by the microcontroller. Finally, the microcontroller calculates the blood oxygen saturation and heart rate and displays the results on the screen. This entire process happens within seconds, providing fast and reliable measurements. In conclusion, a pulse oximeter is an important biomedical device used to monitor blood oxygen saturation and heart rate. The MOSFET plays a critical role as an electronic switch by controlling the operation of the red and infrared LEDs. Its fast switching capability ensures accurate signal acquisition, while its low power consumption improves battery efficiency and portability. Therefore, the MOSFET is an essential component that enables modern pulse oximeters to operate accurately, efficiently, and reliably. That's all. Thank you so much for your attention.